This is a great part B question, mainly because as you glance at it there, it covers so many different topics, right? So like at first glance, it doesn't really look like a calculus question, right? It looks like a trigonometric functions and graphs question. You see your cos and your sine in there. Something to do with functions. You can see there's to do with radians. Okay, we have the unit circle in there. There could be a bit of coordinate geometry for all we know in here. It doesn't really look like a differentiation question, as you can see, right? But then as soon as you get down here, you see it's something to do with calculus. You see maximum area, find the maximum area and things like that. And finally, you have this rates of change question, right, which is one of the more harder differentiation questions really that you can be asked. So that's thrown in there as a part B, which is completely separate to everything you do in part A. But and this would probably have been one of the harder questions on the paper this year. Now let's start off with this one, and like at first glance a lot of students would be turned off by this. Just it looks quite complicated, but in fact if you look at it, what are we actually looking for, right? So we're looking for the coordinates of x, y in terms of pi, or in terms of theta, sorry, right? So if we just take this triangle here, okay, and let's just draw it out here kind of separately here, right? We know that the hypotenuse of this triangle is 5, and if we can figure out what that distance is there, well, that's our x value here. And if we can figure out what that distance is there, well, that's our y value there, right? So we're trying to figure out what x and y is. Okay, so like this is a junior cert trigonometry question. If I were to find the value of x in terms of theta, I'd say that this is the adjacent of the hypotenuse. So cos of theta is equal to x over 5. But we want to know what x is. So x is equal to 5 cos theta. Okay, so that's our x value in this case. And we do the same then with this, except it's sine. Right, so opposite over hypotenuse, so sine of theta is equal to y over 5, but we want to know what y is, so it's 5 sine theta. Okay, so that's essentially all we're trying to do, and so the values of a and b are 5 and 5. Okay, so that's the coordinates now of x and y in terms of theta. Now this again looks like a very complicated question, right? And again, this will kind of turn students off here, but a good student here will spot that this is actually an identities question. Okay, so the trigonometric identities, when you see things like sine 2 theta, that's a bit of a hint there that it's something to do with these identities here, in particular this one here, sine of 2a is equal to 2 sine a cos a. Okay, so just keep that in mind as we go through this question. Now what are we trying to do? We're trying to find the area of the rectangle, right? So this rectangle here. Now what do we know about this rectangle? Well, we know that this distance here is 5 sine theta. We know that this distance here is 5 cos theta. So if we want to get the entire rectangle, well, from there to there must be 10 cos theta. Let's just draw this out a bit bigger. So that must be 10 cos theta across, and that must be 10 sine theta down. So obviously if you want to get the area, it's length by width. So it's 10 sine theta multiplied by 10 cos theta, which is 100 sine theta cos theta. Now, how are we going to turn this into this? Alright, well now we use this formula here, so we can rewrite this. If we take 50 out of this, we're left with 2 sine theta cos theta, and lo and behold, that's the identity here that we're looking at. So instead of 2 sine theta cos theta, we can change it with sine 2 theta, right, which is that, and that's pretty much what we were looking for here. Now here they give you a nice little clue here that it's calculus that you need to use, but like most good students will know that as soon as you see maximum in a situation like this, it must be something to do with differentiation. And even if you're not quite sure what's happening here, how do we show that the area is a square? That'll become obvious towards the end. But as soon as you see maximum, you know that it's to find the maximum point, you get the derivative, put it equal to 0, and solve. So we need to find the derivative of the function that we were using. Okay, and again, that's quite easy differentiation, really. We just need to differentiate this, right? And we know well that to differentiate sine 2 theta just goes to cos 2 theta. The 50 stays the same, but the trick is then to multiply the entire thing by the derivative of the angle, right? So this is where your differentiation skills need to be top notch, right? You shouldn't even need to think about that, really. How do you differentiate that? Sine goes to cos, the angle stays the same, the 50 stays the same, but you multiply by the derivative of the angle, and then just to simplify that, then we can multiply the 2 by the 50 and get 100 cos 2 theta. Now we need to put this equal to 0 and solve, and this is actually an easy enough equation to solve, right? So if you just, the 100 cancels. If we divide both sides by 100, it's just gone. And if cos 2 theta is equal to 0, well, 2 theta is equal to the inverse cos of 0, okay, which is 90. So therefore theta is equal to 45. Now, how does that prove then that the maximum area is a square? So the angle that would give the maximum area is 45 degrees, right? So if we look at our square, or our rectangle, this was the dimensions of our rectangle, 10 cos theta and 10 sin theta. And if you get cos theta, if you get cos of 45, it comes out as 5 root 2. If you get sine of 45 and multiply by 10, it comes out as 5 root 2. So therefore, the dimensions of that rectangle is actually, the length and width are the same, so therefore it must be a square. Okay, so that's how we finish it off there. Now it says, hence find the maximum area. Well, that's easy enough, right? So we know that that's, for it to have a maximum area, the length has to be 5 root 2. We've shown it up there. The width is 5 root 2, so the area is just that by that. Right, very simple. But look, there's actually another way we could have done this. If you wanted to use calculus in this case, or if you wanted to use the original function, right? So the original function was 50 sine 2 theta. So if you just put 45 in there, right, you could actually get 50 as well. Right? So either way is perfectly fine there. Now let's just visualize what that answer actually means. So we got an answer of 45 degrees. So it's what angle gives this shape its maximum area, right? So that was the question was, and you think that, okay, if I had a small angle here, then the rectangle is going to be quite small. So you'd be kind of thinking, well, surely if I just make the angle as big as possible, that'll make the area of this rectangle very big, right? But if I make the angle bigger than, quite big, like nearly 60 degrees, I just picked these two random angles here now. If I make a big angle here, you can see that there's actually not much difference between this rectangle and this rectangle, right? And it definitely isn't the case that the bigger the angle, the bigger the rectangle, right? Whereas if I make an angle of 45 degrees, well, that rectangle, well, it's a square now actually, that rectangle is the maximum possible area that we can possibly have. Okay, so that's just kind of the meaning behind the solution to all of this. Now, this question is probably one of the more difficult questions, as I mentioned earlier, on this whole paper. I'd say this year, this was probably one of the harder questions. Right, it covers everything really. It's called a rates of change question, but it's a rates of change where there's 3 different variables. Okay, and like you either know how to do these, you're either familiar with these, or you're not. If you're not familiar with these at all, this won't make a lot of sense what I'm about to say now. So make sure, if you are familiar with them, you know, there is a kind of, these are quite routine questions, if you know what I mean, all right? So like if you're familiar with them, there's a kind of a step formula to it, and the more familiar you are with them, the better it gets, right? So this is the way I approach it anyway. Okay, so first thing I try and look for is, what rate am I looking for? Right? And you can see it in here. Find the rate at which the length of the person's shadow, which is x, is changing over time. Okay, and it's just assumed it's over time. So we're looking for dx dt, right? What rate is x changing over time? Okay, so that's the first thing you look for. The next thing then you say is, what rate do you have to be given some rate? Now the rate we're given is 1.5 meters per second. Now what is that? That's the speed that the person is walking towards the light, and that distance towards the light is L, right? So we have dl dt, right, which is 1.5. Okay, now here's the interesting thing here. We now use the chain rule to find this. So if we're looking for this, and we have this, well, what can we multiply this by to give you this? Well, the answer is dx dl. Now, why is that? Well, if I, just simple rules of fractions, if I multiply this by this, the dl's will cancel, and I'll be left with dx dt. So if I can find this, if I can find this, then I can find this. Okay, so how do I find that? Well, I need now an equation in x and L. So an equation with x and L in it, and I'm going to differentiate that then to get dx dl. So if I can find an equation of x in terms of L, I can just differentiate that to get dx dl. Okay, so again, if you're not following this, if you're not familiar with this, that's quite complicated, but otherwise you should be kind of following along here. And the big trick here then, and this is the one that will separate the good students from the really strong students, is it's similar triangles that we're going to use here. Okay, so these two triangles, the big entire triangle and the small triangle, are similar triangles, and we can use our rule of similar triangles to get an equation with x and L in it. Right, so x plus L over x is equal to 5 over 2. We can now rearrange this, so get rid of the fractions, rearrange it so that x is on its own. So now we have an equation of x in terms of L, and if we differentiate that, then we're left with dx dl is 2/3, and that's what we were looking for all along. So we now have dx dl, we have dl dt, and because of the chain rule, if I multiply that by that, I get that. So my dx dt is 1 meters per second. Right? And what that translates as is, as the person is walking at 1.5 meters per second towards the light, his shadow, or her shadow, is increasing at 1 meters per second. Okay, so that's a great question, quite a challenging question, but if you're familiar with these, that should hopefully make sense.